will talk about object field. And okay, my name doesn't change. Okay. Object in 4D start with V14 with a variable, C object on array object on all the other command object, obey-get, obey set, obey is defined. And in V15, we have object fields with curly bracket. It's based on JSON, like this simple one, or this one. But that's more than JSON. In fact, with obey set, we can use a pointer on a table or a field. That's really efficient. And we can have a nice way to reduce the number of variables in your application, thanks to that. But that's not the subject for the moment. For the moment, we will have an idea to use object field efficiently. So, to give me a support for my demonstration, I use a user story. That's the user story. I want help a nutritionist to build a database. Okay, I will propose a solution. So the solution, for this solution, I need a nutrition database. Looking on the internet, and I found Open Food Fact is an open source database available at this address, and with a free open source license to use the data. So it's nice. We have a website for this. And for example, for this Nutella element, you can have some information, some detail about fat, about sugar, on something like this. Not really about vitamin, but for this one. Okay, I have a source of data, but now I want to download the data. To download the data, it's an open source database, so we can download in a CSV format, like this. It's a little file, but it's enough to have data to start a new database. This data is in Unicode, it's flat, it's a tab return format, and we have 159 columns, so 159 field in 4D. Now, it's time to import those data into a blank database. If I ask a question like this, how to import into 4D, maybe I will have different suggestions, like this one. It's easy, use only a flat database, or maybe if we are in a forum, immediately another people say, no way, you need to use a relational database. And as you come in the summit, you will answer, no, we show field, object field, so you need to be modern and to use 4D with object field. What's the good answer? So I don't know. So I test. A flat database, like this. Okay. A set of relational database, or a table with object field. Okay. Just for this, to compare similar situation, I had some tables to have detail of the category, the blend, the additive, but it's not mandatory for store the data. It's just to have a similar request. So it's time to have a report for the 3 versions. We have the size of the data, but that's not all. We need some indexes. In the relational database, you have link between the table, so it's necessary to take care of the size of the indexes. Okay, in green. So with the flat, we have no index. With object, we need a little one, and with a relational database, we need a lot of indexes. Okay, we have 3 versions of the structure. So it's time to make some queries. The first one is a search for a country in a flat database. So for a country, we want to perform a quick search, so we need an index. Immediately, the question is B-tree or cluster. In this situation, I test both, and I think cluster is better. For country, we have repeated values, so it's not a surprise. So now it's time to code. Okay. It's my test case. And the time to perform the loop is 3 seconds. Okay, an easy one. A search in a structure with relational tables. So that's this part of my structure. No new index is necessary. In fact, we have already indexes when we draw this structure. So the request is here with a query by formula, perform the 2 links, and the time to search is a double, 6 seconds. Okay. On a search in a table with object fields. That's my table. Of course, country. I have data like this. It's an array of countries. So we need an index too. And with object field, we don't have choice. It's automatic. Maybe I prefer change this word because it's, for me, it's magic. It's and it's only 200 kilobytes. And that's the code for the same test case. A query by attribute, and the time to perform this loop is half a second. Okay. So it's time to report after a simple search. I need some new index. It's not visible, really visible, but here we have some new index in yellow. It's just a little bit. Okay. On the time, in red, it's like this. You have two scale. Sorry. On the bottom is the size, on the top is the time. Okay, more complex now. We want to search, for example, food with vitamin C. It's good for health, so we want to buy someone. Okay. I start with the relational table. That's this part of the structure. Again, no new index is mandatory to perform the request. So we search a label in the nutrition type, and we propagate the result into the element table, thanks to query by formula again. The time for this is 3 seconds. With object field, element, and a new field, nutrition, with some information like this. Look at the sodium, it's very precise weight. It's real data. Okay. Now we need an index for this. Magic, automatic, and 3.7 megabyte only. The code to search vitamin C into the element table is like this, in loop. On the time, 150 milliseconds, really quick compared to the relational database. And for the flat table, we have 96 different types of nutriments. So 96 different fields in the flat table. Yes, you have the flat table. That's all this part. So 96 different search on 96 new indexes. And it costs 102.7 megabytes. Okay. The code, it's a little bit more complex, but you will have this, those databases on the key or in a FTP after, I'm not sure. The time is 1.3 seconds. So the report after a complete search is like this. The size of the data, the indexes, and the new indexes. Okay. Flat is efficient, but need a lot of indexes. And the speed, relational is not the best way for the moment. With object is interesting. It's efficient and compact. Okay, but that's my test is only with a database with only one table, one main table. In a complex structure, we have to take care of the cache. So take a look on the cache. For this screenshot, I will just click. My cache is reduced to simulate an empty cache, because I don't have a big database with a lot of object field. But that's the same size of cache for the 3 version. That's this picture is a tool built by Roland on the first row. And we did this tool last year in San Antonio. And we have a tech note on it's available on the FTP. It's a get measure, it's a component. If you want more detail about this, go to Roland. So, on the first line, you show the cache read, second disk read, cache miss. Cache miss is when you don't find an information into the cache you need to read in the disk. On disk write, okay, disk write is flat. In my test, I only read data. For relational database and for object field, the first mountain picture is the first test, and immediately I loop again the same test. In flat database, I read again all data on the disk. That's not the case for the other version. Why? Because with a flat database, we need a lot of index. As my test randomly change the field, we need to change the index, and we need a lot of room for the indexes. So it's a huge perturbation for the cache. To have a nice situation for the flat database, I need to change this. I want this situation, and for this I need 50 megabytes more in my cache. It's just a little part of the database, but it uses a lot of cache. So it's important. Okay. This morning, GPR say we have 2 extreme situations. In fact, in the demo during the keynote, we use only one field to store all the data. But in the real life, that's not a good idea. In my test, I use this structure here with some fields. My choice is 6 object fields. Why? Nutrition replace 96 regular fields. For me, it's enough. I stop. It's consistent, all same type of data, and it's even huge. Okay, stop here. Second, only two object fields are indexed. In fact, maybe for my user, don't make a search on all the information in the object field. So with a split between several object fields, I can choose which part it's indexed or not. If I have only one field, all is indexed, but it costs some size in the data file. Okay, additive category labels are just array of value. For categories, you have some value, just one after another one. That's different with information. Information is really more structured. You have this database on the USB key, so you can explore the repartition of all the information. Okay, so how to build a field respecting the rules? In fact, we have some rules. We are based on JSON, so we have rules of JSON. A new user story to store a means of communication in an object field. For example, you start with a phone number, a fax, a mobile, a Skype, an email, and that's all. And you, after sharing a voluto with George, you have another phone number. And you want to add this phone number in your record. It's nice to have the private phone of George, but it's not possible. In fact, repeated attributes are not allowed. That's a problem. So this structure of the object is better. You have a type, phone, fax, mobile, Skype, email, maybe Snapchat, Facebook. And you may add an extra attribute for observation. And the second attribute is number, but for a Skype is a pseudo, for an email is an address. The structure must evolve with the type of the communication type. Okay, so we have this object in an object field, in a record. To search inside this object, we have query by attribute. We query on the table contact, in the field contact communication, and after we have a path. This path is come. Come here is this part of the object. And after, the square bracket is an array. This part, subpart of the communication object. Dot number. Number is here, 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 or here. You have four attribute number in the array. So the answer is the facts, in fact. That's easy for a simple search, but for a multiple search is more complex. In fact, if with a star you link two query by attribute, you have this search. So the answer is here. And term type equal phone is here. Or here. This record with this object respects the rule. So you will find this record in your selection. The star at the end of the first line of the request link the query, but don't say that's in the same sub-object in the array. Now, today in Portland, it's not possible. But we have error realize for the next step. So today we have a problem if we don't take care of this situation. You may have a problem. Okay. Something really important is combined search. Query by attribute with a start at the end is not finished. On query. Yes, that's possible. To link query by attribute on query with a star, by a star. That's the only set of command in 4D in this situation, link by a star with a different name of command. Really interesting. So I give a smiley. I like it. Okay. Organize the data. Okay. Back to my hotel database with room. In 14 and 15. In 14, I have a linked table to describe all the rooms. In the second version, just an object field. And the ID is to transfer all the information in the object field. Okay? I have different ways to organize the object. Maybe this, or this one, or this one, or this one. What is the best one? Which is the best one? Probably not this one, because it's two attributes in one. It's not really a good idea. This one, you have one type, applies a number. It's strange to reverse the order. So I don't like this one. The two other ones are interesting. So we will study the yellow one and the blue one. To have an idea of the data, we have a new command in V15, distant attribute pass. hotel rooms into an array of paths. It's a text array. So I launch the command, and the result is like this. Double is the object, the sub-object in my object. Double dot number, double dot price, and that's the same for all the attribute, all the paths. Distant attribute paths work on the selection, give you an information about the selection of records on the main table. For the blue one, first, in the array of paths, you will have rooms. After rooms dot square bracket dot array, rooms dot array dot number dot price dot type. On is not finished. Did you have an ID for the last one? Nobody? Okay. Room length give you the number of items inside the array of rooms. Okay, that's a virtual attribute, a virtual path automatically added by 4D. Yes. Use the data. With this situation, we have all the paths available. With distant attribute value, first parameter is a field, second parameter is a path, third parameter is an array. And the result is an array like this. On 56, the value for the single, the price of the single, is in the array. But the 52, the price for a twin, is not in the array, of course. With the blue version, distant value, rooms dot array dot price into an array of price. The result is here. We have 56 and 52, 74, 96. Okay. All the price correspond to this path. It's not possible to restrict just for the single. So it's really important to imagine the future request before choose your structure. Okay, sum is just an enhancement of the command sum, max, min, on average, with, in second optional parameter, you have the path. With the blue version, sum of all the room on maximum type of room in an hotel. It's possible, like this. A new op. In fact, with object field, we have it's easy to use on search. Second is red, I. Yes, you can't sort by an object field for the moment. Maybe in the next episode, we will have a solution on the, maybe our father made something. 3. No? Yeah, but it's finished. No, no more. Too late. 3. Okay, yes. Polymorphous and flexible. In fact, you can choose exactly what you want. It's flexible. You have some rules, but not too much rules. It's dynamic. You can change when you want. So it's the word on the wave is schemaless. And it's simpler for complex structure. So, schemaless. Schemaless, imagine you are a bike reseller. So, in your stock, you have some tire for a road bike, and you need to describe this tire with some attribute. But for mountain bike, that's not the same attributes. And for the cassette, for the speed, you need different attribute. And for the saddle, that's the same things. And for the pedal. Okay? All those information, you remove the data, just the attribute, and now you have template. You can draw a new table, component type, with an object field, take carat template, this field, and store in records all the template, one for each type of component. Now, for the component table, when you create a new component, you copy the template to start the new component. You enter the value. And you can adapt each component with an additional attribute or remove another attribute as you want. So it's not exactly schemaless. It's more assisted schemaless in this situation. Okay? And thanks to this situation, we can sell some special article for people who made the music rap. You know the rap? And they use bicycle like this. And for this bicycle, you want to change the saddle, so you need a new component for the saddle, And for this saddle, you need a new attribute, body compatible or not. Okay? So that's the idea. You have a template in a master record in the type of component. You use this template and you evolve the template in life for each component. And after, with the distant attribute path, you may have a description of all the extra paths of the extra attribute like body compatible, so you can use without coding nothing new in your database. Just give the ability to add a new attribute. Okay, that's time for question and answer. I'm a little bit fast, I think so, but.
I was going to say the trickiest part, obviously, in this kind of a database, it makes a lot of sense for some of the purposes, but you almost, it's hard to see the data unless you see it in that thing. So you're going to have to write a completely different, flexible form version of objects so that they know how to bind to the various types of templates.
Yes.
Probably get you started, right?
Yes, it's nice to describe information very different between one record and another record. For example, it's a very bad idea to use an object for a contact to store the family name, last name, first name. No sense for this. But to have a description of the university cursus, it's a good idea because no one has the same cursus. Okay, it's the difficulty. It's we have no global rules. It's depend of the situation. It's why we speak about schemaless. But that's the difficulty, but that's the power too, in the same time. Okay, thanks.